class.
Good afternoon, ma'am.
Yeah. So today we are going to discuss about clustering. Means how we can perform clustering in case of means when your input data is text. Okay. So same process. Just the thing is, I need to explain the types of clustering. Okay. So have you studied this topic in machine learning? Is this is means discussed in machine learning subject?
No, ma'am.
No. Acha, KNN, K mean, anything like that? K nearest neighbor, K means algorithm.
Yes, ma'am.
Which one? Both? Both is completed.
No, KNN was there.
Okay, so that means clustering is not discussed. Okay, fine. So first we'll see what is clustering actually. So clustering is the process, means as the name suggests, cluster. If you have given some set of data, so what you have to do? You need to club them, you need to group them on the basis of some characteristic. Okay, and this grouping is known as clustering. So, so that means each cluster is going to represent that they are the elements which are present in a cluster are having similar characteristic. Okay, so suppose in case of suppose text clustering, suppose we have created one cluster of all the words which are having same meaning, same sense. Okay, so this is a basic definition of clustering. Okay, now clustering can be of three types. So first one is exclusive. Okay, first one is exclusive clustering. So what is exclusive clustering? Let me write here. Exclusive clustering. Okay, second is overlapping based clustering, and third is hierarchical. Okay, so these are three types of clustering. So exclusive clustering is also known as hard clustering. Overlapping has also other name, soft clustering. Okay, now why it is hard clustering and why it is soft clustering? So first of all we need to understand exclusive. So as the name suggests, that when all the items, all the elements belong exclusively to one cluster only, that means all the data points belongs to different cluster, then this type of cluster representing exclusive clustering. And when you have some data points which which belongs to both the cluster, like these points belongs to cluster 1 and cluster 2 both, so that's why it is called as overlapping clustering. Okay, that's why it is also called as soft cluster, right? And when there is parent child relationship between the data points, then it is called as hierarchical relationship or hierarchical clustering. So it is like parent child relation, means there is going to be one main cluster and these clusters are like having some characteristic of the main cluster. Okay, like parent child relationship. Okay, So you need to identify some examples which belongs to these clustering, these different types of clusterings. Okay. Now, so exclusive clustering. So in exclusive clustering, we have an algorithm, and that is K-mean, K-mean clustering algorithm. And here we have C-mean clustering algorithm, C-mean, or you can say fuzzy mean algorithm, fuzzy clustering. Okay, and again, hierarchical is again divided into 3 parts. Okay, so 3 parts means hierarchical clustering has 3 types, and that depends on how we are computing the distance between 2 points. So hierarchical clustering types depend on how we are computing distance between points. Okay, so yeah, that's like overview of the clustering. Now we will see what is K-mean clustering. Okay, K-mean clustering. So in K-mean clustering, there are some basic things like first, like as a name suggests, K-means. Mean, you already know, mean, median, mode. So here, means are representing that mean value, means out of some set of data, what is the mean? Okay, now K is representing number of clusters, number of clusters you are going to have in the given set of data. Okay, so that means this K-mean clustering algorithm depends on number of clusters K, and here, so actually this is the disadvantage actually. So suppose, because initially you need to, in this algorithm you need to provide K. Okay, and if you have given wrong assumption for K, then data will not be clustered properly, and the data forcefully allocated to these K clusters. Okay, so this is the demerits, or you can say disadvantages of K-means. Whereas it has some advantages also, because this is basic type of clustering algorithm. Okay, and that's why it is very simple and also easily understandable. And here items automatically assigned to different clusters. Okay, so because of the disadvantage that here we need to provide K initially, so that is resolved by hierarchical clustering. Okay, in hierarchical clustering, no need to provide the initial value of centroids or initial value of your a number of clusters. Okay, so, and one more thing I want to mention in K-means algorithm, for finding better value, or you can say optimum value of K, there is one method, and that method is known as elbow method. Elbow method. So elbow method, what it does, that it will try to, means in elbow method we need to find clustering, means we perform clustering on different values of K, and the value of K on which you you will see that after increasing or decreasing the value of K, you will get that the best best clustering. Okay, okay, let me draw the diagram. Suppose this is the graph. Okay, so here this x-axis representing number of clusters. Okay, and y-axis is representing, you can say, distortion. Okay, So here you can see that this point is representing that after this point, if you increase the value of k, number of clusters are what? K. If you increase the value of k, you are going to get the same distortion value. So that means this is the optimum value of k. Okay, after that, result is stable. Okay, graph is stabilized after this point. So this is one of the method for finding the optimal value of k in k-means algorithm. Sometimes you can get this question. Okay, how you can find an optimum value of k in k-means algorithm. So for that you have elbow algorithm, means elbow method. Oh, sorry, elbow method. Okay, for finding optimum value of k. Now we'll see hierarchical clustering. Okay, so as I have already told, it is used for representing parent-child relationship. Okay, so actually it is an alternative approach which builds a hierarchy from the bottom up, or you can say top-down approach, top-down manner, and not required to specify the number of clusters beforehand. Okay, and the main output of the hierarchical clustering is a dendrogram. Okay, dendrogram. This is a keyword. We will see further what is the definition of this one. Or you can say that hierarchical clustering is represented in terms of dendrogram. Okay. And one more thing I wanted to show you here. This is here. This is a link where this is a website where you can visualize the k-means clustering. Okay. So here what is given? So with this new point button, I can generate different set of data points. And here you can see we have already fixed 3 clusters. So that's why these green, yellow, and blue are representing 3 different centroids. So in k-means algorithm, what we are supposed to do? Initially, we have to select 3 points or k points as the initial centroid. So this is shown in this figure. Now we will, so for updating, I will click this button, find closed centroid. So you can see that. Okay. So, and the problem with the k-means is the performance of k-means algorithm depends on the selection of clusters, selection of initial clusters. If the initial clusters, initial centroids are wrong, then you are going to get wrong number of clusters or wrong clustering output. Okay, so here you can see that clustering is not done properly. Not done properly because the centroids which we have selected are not correctly selected. So let me take new centroids. So this is again a new data set points and new 3 different centroids, means 3 clusters and 3 data points. These 3 is green, yellow, and blue are representing 3 initial centroids. And if I try to find closest centroid for them, so you can see that at every step it is trying to adjust the centroids. So here every time it is trying to generate okay. So yeah, means you can use this online tool to understand how the algorithm is working. Okay. Okay, now we'll see hierarchical clustering. So here we need to choose, means in case of hierarchical clustering, we need to choose a way to measure the dissimilarity between groups. Okay. Whereas in k-means clustering, what we do, how we find distance using Euclidean distance. Okay. Or there are other difference matrix also, like cosine distance, or like you can try with different distance matrix, and whichever will give accurate result, that distance matrix you can select. Generally researchers use Euclidean distance. Okay. Now here you have seen one word, linkage. Linkage means how you can find the dissimilarity between groups in case of hierarchical clustering. Okay. So given the linkage, hierarchical clustering produces a sequence of clusterings assignment. And at one end, all points are in either own cluster. At the other end, all points are in one cluster. So you will see that what does that mean. Okay. Now this hierarchical clustering can be divided into two main parts. Okay, agglomerative and divisive. Agglomerative hierarchical clustering and divisive hierarchical clustering. So agglomerative means bottom up, bottom to up. So we know that root is always going to, means top one is always going to represent the all data points in single cluster. So here in case of agglomerative, the approach is bottom to up. Bottom means all points are individually going to be considered as a single cluster. Okay, so that is what written here. Start with all points in their own group, means each point is representing a single cluster, individual cluster, and until there is only one cluster, repeatedly merge the two groups that have the smallest dissimilarity. Okay, so very easy to understand. What does that mean? Means suppose you are having these five points. Suppose 1, 2, 3, 4, 5. Okay, so yeah, bottom to up approach. So we need to make like this. And 1, 2, 3, 4, 5. So suppose this 1 and 2 are having the smallest distance, so they are merged. Okay, here suppose they are merged. Now which two need to be merged? Suppose these two are merged. So like this is what bottom to up approach. Okay, so this is representing agglomerative. Divisive means top to down, but agglomerative is more often used than divisive. As per the researcher analysis, it is experienced that agglomerative give better result than the divisive algorithm. Okay, so for that reason we are going to explore agglomerative in this discussion. Okay, so here they have represented with one algorithm, one example. So these are points. So suppose here 7 samples are present, means 7 elements are present in this two-dimensional space. This is two-dimensional space, no, x and y. Okay, so each point should be having some x and y value, na? Right? So we are assuming that each these points are representing some x and y value. So on the basis, okay, so from the figure, from this space diagram, you can see that which one is closer. So here it is very clear that 2 and 3 are very close. That's why at the first step, all are considered as individual clusters. So that means this is cluster 1, this is cluster 2, this is cluster 3, this is 4, this is 5, this is 6, and this is cluster number 7 at the initial stage. And we are using agglomerative approach. So this is what bottom to up approach. So bottom to up approach means at the bottom level 7 clusters you have. Now what was the second step? You need to find the You need to select 2 points which are closest. Closest means the distance is minimum. So 2 and 3 are closest. So they form a single cluster at the second stage. Okay. Now, by applying distance matrix, it can be seen that 1 and 7 are more closer. That's why here 1 and 7 are merged. Now, after that, by applying distance matrix, they have seen that 4 and 5 are more closer. So that's why 4 and 5 are merged. Further, they have seen that this 6 are more closer to 2 and 3 than remaining 2 clusters. So that's why this is again clubbed. Okay, so that's why 2, 3, 6 is here. Now further, it is seen that this cluster is more closer to this 4 and 5. Okay, so that's why they are merged, and finally they all are merged. So that's why it is a bottom to up approach, no? Bottom to up, and the root is going to represent the main cluster, single. Now here again, the point is how anyone can define how many cluster does it have, because finally you have one cluster, root is representing one cluster, and bottom is representing means each individual as a single cluster. Then we need to find the optimum number of clusters, right? That is the reason of clustering. So with this approach, you can see that neither top one nor the bottom one is representing number of clusters. In the middle of somewhere, you can find the number of clusters. For that, we need to there is one approach that is called as cut approach. Means you need to cut this tree architecture or this hierarchical architecture at some height, and below that height you can find the number of clusters. We will see that in further slides how we can find the number of clusters. Okay, now so whatever we have developed here, in whatever manner we have merged 2 points, that is represented here with the dendrograms. Okay, so this representation is known as dendrogram. Okay, this dendrogram is representing hierarchical representation of data points. Okay, so each point here you can see that each point is representing single cluster, right? And here this is what representing this. Here you can see some values are written, right? So what these values are representing? These values are actually representing how far these 2 points are. So here you can see that this is representing one cluster. Okay, these 2 merged. Now these 2 are merged. Okay, further these 2 are merged, and finally you have 6 merged to 2, 3. And after that, here we have done one merging, and this is the final merging. Okay, so their height, you can see, even we are merging 2 points, but their height is different. Here height is different, here merging height is different, you know? So why this is different? Because this height is representing how far these 2 points are. So according to, okay, let me remove all these. According to the height, which one is having the minimum height in the merging? 2 and 3, right? So let's verify that. You can see here 2 and 3 are the closest point in the given all these set of points, right? So that's why the height is smaller for this one. So it seems to be around 0.1, means they are around 0.1 distance apart, right? And it seems to be around 0.25, these 1 and 7. The height seems to be at 0.25. That means they are seem to be at 0.25 distance apart. Okay, so this height is having some value, some importance. Okay, it is not like no randomly we have taken this height. No, this height has some meaning. Okay, so yeah, according to that they have merged. Now I have told you, see, at the bottom you have how many clusters? 7. And at the top you have one cluster. This is representing one cluster now. So where you get the optimum number of clusters? Suppose if I perform a cut over here, then how many clusters do you have? This is 1, this is 2, this is 3 cluster. Okay. Similarly, if I perform cut over here, then how many uh, clusters we are going to get? 1, okay, and 2, 3, and 4 clusters. So that means here also at which height you can perform cut, that is going to generate different clusters. But for selecting height also there is a rule. Okay, because this height is representing what is the maximum distance between any points, any given points. Okay, so we need to take some measurement value for this height. Okay, that we will see further. So we'll see step by step how the things are happening. Now about dendrogram, some information is given. It is a convenient graphic to display a hierarchical sequence of clustering, and it is like a tree structure. Each node represents a group. Okay, so you can read it out later. Okay, now linkage, I have told you one thing. No? So linkage is like to generate, linkage is like how we can generate this hierarchical relationship, like this bottom-up approach, how this dendrogram type of diagram you can generate. Okay, so that is based on the linkage property. Linkage property means how you are going to find the distance or dissimilarity between the points. So for that we have 3 types: single linkage, complete linkage, and then average linkage. Single linkage means when you are going to find minimum distance between the points. Minimum distance. So let me make you understand what does that mean. Single linkage means it is written nearest neighbor linkage. Nearest neighbor. The dissimilarity between G and H is the smallest dissimilarity between 2 points in opposite group. So here you can see that suppose this is one cluster, okay, and this is another cluster. So the smallest dissimilarity between 2 points in opposite groups. So this cluster are having some n number of points, this cluster are having some m number of points. So which out of this n points, which point is closer to this cluster? Somewhere this point, and this point from the second cluster. So means point 1 and point 2 are representing the closest point from these 2 clusters. And what is their minimum distance? That we are considering. We are not, so here we are taking the best case. Okay, so here you can see that we are considering the best case, right? And further you will see that we are having different type of linkage, and that is complete linkage. So let's go there. So now you understand what is single linkage. In single linkage, we are trying to find the distance between the points, means minimum distance between the points of 2 different clusters. Okay. Whereas, okay, yeah. So here you can see how the graph is looking, how the dendrogram is. So yeah, so this is the 2D space where data samples are represented, and this is their corresponding tendogram. And here you can see that height is varying from 0 to 1. That means distance between these points are varying from 0 to 1. 0 means individual cluster, 1 means entire cluster, means all point in one cluster. Okay, so here you can see that, okay, here yeah, here let's see this cut interpretation, means at which point we need to perform the cut operation. Cut operation means to find the total number of clusters. Okay, so for each point xi, there is another point xj in its cluster with dij, means distance between xi and xj should be less than or equals to 0.9. Okay, so this is the interpretation, cut interpretation for single linkage. Okay, means the distance between the points in a cluster should be less than from a given threshold value. So that we need to check. It is not like that in every single linkage you are going to get this value. No. When you will perform distance value, you will see that from which point you are going to get this dij less than. This condition needs to be satisfied, and this is some threshold value. So that you need to identify after performing the experiment. Okay, now complete linkage. So in the single linkage, we have seen that we need to find the smallest distance between two groups. Here we need to find the largest distance between two clusters. Okay, largest distance. So you can see that here, same cluster, same set of points, but here we are trying to find the distance between these two clusters on the basis of their extreme points. So that means here they are considering the worst case. Okay, worst case. So on that basis, the generated cluster is different. Okay, generated cluster is different. So here you can see that this complete linkage is generating better cluster than the single linkage. And here the cut interpretation is done at height 5. Why so? Because the condition is satisfied at 5. For each point xi, every point xj in its cluster satisfy dij less than equals to 5. That's why we have selected cut at 5. So how many clusters are generated here? 1, 2, and 3 cluster. Okay. So that's how we are going to identify the cluster in different type of linkage. Now, what is next? Average linkage. Average linkage, in the first one, in a single linkage, we are considering closest distance between groups. In the complete linkage, we are considering means farthest distance between the groups. And in the average linkage, we are finding the average distance between the groups. Okay, that is the difference. So out of these three, we have seen that the average one is giving better clustering pattern than the above two techniques. And but average has its own problem, own limitation. So limitation is here, finding the cut interpretation is very difficult. Okay, because here we are applying average technique. So because of that, finding at which height we need to perform this cut, that is a bit confusing. Okay. Okay. Wait a minute, class. I'm getting a call from office. Uh, Class, actually, I have a meeting. So, yeah, actually, it's not much remaining. Everything I have already explained about this single linkage, complete linkage, and everything. And I have also told you the limitation. And from this diagram, you can see that the last one, Miss Average one, is giving better clustering technique than the remaining one. Okay. So I'll wrap it up here, and we'll discuss some new topic tomorrow. Okay. Class, am I audible?
Okay, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yeah, yeah. Thank you, everyone.
Yes,
Please.
ma'am.
Okay.